Hi everyone, today we're going to go over 4.2a, the one and only section that is the entire umbrella of trigonometry, the best section in my opinion, the unit circle. Alright, this is going to be a lot of information. We've talked about this in class time and time again. It's going to be a lot. There are tons of videos on YouTube aside from mine. Alright, you can look up tricks. There's a little hand trick that talks about just the first quadrant of all of the things I'm about to show you. If you can memorize that trick, because that is something that I use myself, if you can memorize that trick, you're golden. There are plenty of other tricks as well, and we'll talk about those as well. That will be part of your homework tonight, is to look up a video, look up a trick, and see if you can memorize the unit circle accordingly. All right? You need to have this memorized. For sure, it will be a quiz from start to finish next class, all right? So it needs to be in your head, ready to go. So let's get started. The unit circle, again, we've talked about unit circle. When we hear unit, we're thinking one, and that is where it's being used, in the radius. It's because it's a circle with a radius of 1. And it centers at the origin of a rectangular coordinate system. That just means it's the same as your typical XY coordinate system that you're used to. All right, so it's still going to be in the same XY coordinate plane, but this time we're going to be talking about a circle, and the radius will always be 1. All right, and as a refresher, remember we're not talking about X and Y's any longer. We're actually going to talk about cosine and sine. So remember that cosine is pairing with x and y is pairing with sine. So whenever I ask for your x or your cosine, we are referring to your x every time, your x coordinate. Whenever I'm asking you for your sine, you are referring to your y coordinate. So on the unit circle, this is what your typical unit circle would look like, all right? We're going to just talk about one reference angle at a time. There's a total of, let's say 3 different reference angles. And remember, when we talked about reference angles in 4.4b, if we knew the first quadrant every single time, then we knew every quadrant after that. So if you memorize the first 20 or so things in the first quadrant, you got everything else down pat in all the other quadrants. So I'm going to show you how they relate to one another, okay? So the way the unit circle works, we're talking about a 30-degree reference angle. So if I look in that first quadrant, the 30 degrees is going to be this first angle here. That is my 30 degrees, all right? And with that 30 degrees, we talk about radians. We're going to use it all today. So degrees, radians, and their cosines and sines. So if I were to convert 30 degrees to radians, we would get what's called pi over 6. That pi over 6 is going to mark that spot every single time. And then the way it works is the unit circle creates these triangles. So if I were to take that coordinate on the circle and bring it down, I create this triangle. That's going to give me a 30, 60, 90 triangle, if you remember your special right triangles. All right, that similarity to one another is going to be a 1, 3, 2, a 1, a root 3, and a 2. 1 on your 30, root 3 on your 60, and a 2 on your 90. All opposite sides is what I'm talking about. So, again, that's a special right triangle. You talked about that in geometry. How that comes into play here is when I go in to talk about the cosine and sine coordinates, your x and y's, your cosine, which from angle 30, your adjacent side divided by your hypotenuse, is going to be root 3 over 2. This is part of the stuff that we're going to have to memorize, but there are tricks in doing so. And then if my root 3 is taken, my sine of 30 degrees would be 1 over 2. So again, it's our 30, 60, 90. So this is saying that 2 is my hypotenuse. Technically, I know it's a hypotenuse of 1. We need to just know that at cosine, when I'm talking about 30 degrees, your cosine is root 3 over 2, and your sine is 1 over 2 for every single one. Now remember, if I know one quadrant, I know the other 4, and this is how they're going to relate to one another. In that first quadrant, if I were to reflect it across the y-axis, so I were to take it and basically if your palm was up and then you flip it over and now your palm is down, it's the same exact triangle on this side. Except, of course, it's no longer 30 degrees. It's actually going to be 150 degrees. It's that 180 minus that 30 already. So the entire degree measure would be 150 degrees. This one would be measuring 5 pi over 6. They're all pi 6th measurements when we're talking about 30-degree reference angles. You'll see that pattern here in just a moment. And my cosine is going to be a negative number this time. And guess what? You actually know what that negative is going to be. It's going to be the same cosine from previously. It's just negative root 3 over 2, comma, 1 over 2. Nothing is changing. Once you know one, you know the other. We just have to pay attention to negatives and positives. So if I go into the third quadrant now, I'm talking about this angle here, which is again another 30 degrees, but technically if I were to add the entire circle to get to that angle, it's going to be at 210 degrees. It's not 6 pi over 6 because that would give me to pi, but it's actually going to be 7 pi over 6. And think about your third quadrant. Your cosine is going to be negative. Your sine will also be negative. So when I take those values, it's negative root 3 over 2, negative 1 over 2. That's all I need us to practice today is what our values are going to be in these specific coordinates. And last but not least, in the fourth quadrant, we're going to make like a little bow tie here. The fourth quadrant is another 30 degrees, but of course we're just shy of the full circle. So we are sitting at 330 degrees from there. This time it's going to be 11 pi over 6 because it's just shy of 2 pi. Again, there's tricks to remembering all that information. And my cosine is going to be positive this time, but my sine is going to be negative. So take a look at the patterns. For just a 30-degree reference angle, in the first quadrant, you have pi 6th for radians. The second quadrant, we have 5 pi 6th. Third quadrant, 7 pi 6th, and 11 pi over 6 for the fourth quadrant. All right, those are going to be the one things that we're going to have to memorize that do change. But again, there are tricks to memorizing that. And then the biggest part is once we know one quadrant, we know them all. So match up the pieces. Cosine will always be root 3 over 2 when it comes to a 30-degree reference angle. But it varies on quadrant, whether it's positive, negative. Same thing for sine. It will always be 1 over 2 when it's a 30-degree triangle. And depends on what quadrant yet again. So memorize, memorize, memorize. We will complete an entire unit circle once we are done with these 3 reference angles. So we're going to move into the 45-degree reference angle now. 45 degrees, remember, well, if one quadrant is 90 degrees, then this time we're talking about all the halves. So all these angles here that split each quadrant in half. And of course, they're still building that triangle all the way down to the x-axis. So for the first one, that's just a 45 degree. The ratio for 45 degrees is 1 root 2. So what this means, actually let's start with the radians, sorry. So it's going to be pi fourths is my radians when I convert from 45 degrees to pi fourths. And when I get to the coordinates, it's actually a nice root 2 over 2. Root 2 over 2. All right, again, your cosine is root 2 over 2. And your sine is also root 2 over 2. So the beauty of anything that splits it in half is your sine and your cosine are the exact same. Again, being mindful about when it's positive and when it's negative. So if we hop into the second quadrant, we're still talking about a 45-degree reference angle, but in the fourth quadrant, it's going to be a total of 135 degrees. All right, and what that means, as I'm jumping around here, that means that from my initial side on my x-axis, if I were to open all the way up to this spot here, and I were to close off my terminal side, that is referencing my 135 degrees. That's where I'm getting 135 from. Of course, in that triangle there on the top left quadrant, that second quadrant, the triangle is still a 45-degree angle, but I'm calling it 135 because that's the total angle that it's getting to. So that's where I'm getting those values from. At that part of the quadrant, if you convert to radians, this will be 3 pi over 4. And our coordinate this time is still root 2 over 2, root 2 over 2. But pay attention to which one has to be negative in this quadrant, and that's our cosine. So we want negative root 2 over 2, comma, root 2 over 2. Third quadrant. We have 180 now plus another 45, so that's going to take me to 225. This time it is 5 pi over 4. And my cosine and sine both need to be negative, so they're negative root 2 over 2. Negative root 2 over 2. All right, if you're struggling with the radians, that's fine. There is a pattern to memorize, but remember at the end of the day, if you know what the angle degree measure is, you can still multiply that by pi over 180 and you will get pi over 4. So if you happen to forget the pattern or you don't know how to get the radians, you remember you can always multiply by pi over 180. And so for this last quadrant here, your radians is going to be 7 pi over 4. We're talking about, 315 degrees. And our coordinates are root 2 over 2. Our cosine is positive, but our sine will be negative. All right, for the last one, we got our 30 down, we got our 45 down, and now we have our 60-degree reference angle. So 60 degrees is talking about this one here. That's my 60. And let's go ahead and label all of my 60s. So the next one is this guy here, followed by this one, and then here. So it'd be 60, the next one would be 120, followed by 240, and then 300. And again, you'll see these patterns developing every single time. If I converted 60, I would get pi over 3. That's going to tell me that I have a 1/2 first, then a root 3 over 2. Still labeling your cosines, still your sines. None of that is changing. Second quadrant, this time we're talking about 2 pi over 3. And I have negative 1/2, positive root 3 over 2. Third quadrant is going to be 4 pi over 3. And we have negatives for both. And last but not least, the fourth quadrant is going to be 5 pi over 3, which will be positive 1/2 and negative root 3 over 2. All right. The only ones we did not actually talk about are those 90-degree reference angles. All right, so let me just touch on those here. We've kind of actually already gone over it, at least the 0, pi, and 2 pi. So if I were to have a triangle here, of course, it's not opening at all. It's just that small little line. Our, first our radians, or our degrees would be 0 degrees, and then our radians would also be 0 radians. But my cosine here, remember you have a radius of 1, so that's your 1 comma 0. 1 is your cosine, your x, and sine is 0 because it has no height to it. If I go 90 degrees then, I'm looking at 90 degrees, a right triangle. This time, my radians is going to be pi halves, and it's going to be 0 for my cosine and 1 for my sine. That's where we get that from. Going to the next 90-degree angle, that's 180. That is going to be our pi. We've talked about that already. Half of a circle is pi. And then I have -1 for my cosine and 0 for my sine. And last but not least, this last right triangle is going to be 270 degrees. Should have labeled this one 80. This one's 90. 270 degrees is going to be 3 pi over 2. And that is going to be 0 on my cosine, -1 on my sine. All right. Now, as of right now, I know it looks like we have a full circle showing, but we haven't completed the entire rotation. We've only gone about 3/4 of the way. So if I went back around here again, yes, I'm at 0, but now I've done a full circle. So now I'm at 360 degrees, which is 2 pi, but it's still the coordinates 1, 0. So make sure, depending on how far around the circle you've gone, it could be 0 degrees or it could also be 360 degrees, depending on what we're working with. All right. So that is the reference angles. If we look through here, you'll see the pattern developing. So as I go and I show you the entire unit circle and we go through that, remember, if we know one quadrant, we will know all 4. So let's look and find the unit circle here. This is what we need to memorize, every single piece. Next class, you will get this entire paper, the exact same piece of paper, and asked to fill it out completely from start to finish, right? This is something I would highly recommend that you put on your 8.5 by 11 sheet for your final, and we will also take this into second semester. So don't just throw it away when semester 1 is over. You do want to keep it, right? I'm going to show you the trick that I learned when I was in high school. There is the YouTube video still up on this trick, so if I don't explain it too well, you can still find it. That can be part of your homework again tonight, is to look up the videos for tricks, okay? I'm going to show you the first quadrant, and then we will base every other quadrant off of that after, all right? So just think for a moment. Let's start easy. Let's start at 0, 0, okay? Well, that is here, so I'm going to have 0 degrees, which is also 0 radians. But the coordinate for that would be 1, 0. Pretty simple. I know my radius is 1, so that has to be my cosine. I know I'm at 0 degrees right there, which if I'm at 0 degrees, then I'm also at 0 radians. And then 1, 0 are my cosine and my sine. If I jump up to the next triangle, the next angle, that's my 30 degrees. If I jump up a little bit more, that's my 45 degrees. A little bit more, 60 degrees. And one last time, just to finish off the quadrant, I'm at 90 degrees. All right. Let's see here. I'm going to skip the radians for now. We'll talk about those in just a moment. Remember, to get radians, you can always convert from degrees to radians, but there is a pattern. Now let's go, and we're going to do those cosines and sines. So watch carefully. I'm going to do all my cosines in the first quadrant first, and this is how it's going to work. I'm going to go from 90 down to the 0 degrees. So 90 for cosine, so the first part of the coordinate. I have 0 up top, followed by 1, 2, 3. Okay? I'm going to do that same ladder effect going the other way. 0 was on the 0 degrees, followed by 1, 2, 3, and then I get a 1 on my sign. Now, these are fractions over here on that first quadrant, your 30, 45, 60. The denominators will always be 2's. So I'm going to fill in every denominator with 2's. And then, if you notice, on some of them they had square roots, while others did not. So if I were to take the square root of every single numerator, go back to the ones that say square root of 1. Well, what is the square root of 1? It's just 1. So do I really need a square root on those? No. And that's how we get all of those coordinates in that first quadrant. And then as a rule of thumb, just remember which ones are positive, which ones are negative in that first quadrant. So the only positives, we want cosines positives, and sine is also positive. So negatives have none. It's just asking, is your cosine positive in that quadrant? Is your sine positive in that quadrant? Or are they negative? All right. So there's the pattern for figuring out the coordinates. Now, the pattern for figuring out the radians. You have to kind of have an idea of what they are before we can continue. So I'm going to do every reference angle together. So every coordinate, or every quadrant, excuse me, I keep getting those mixed up. Every quadrant we're going to do back and forth. So I'm going to start with just my 30-degree reference angles like we just did on the previous notes. At 30 degrees, my radians are pi over 6. All right, if I jumped into the second quadrant, I know that this right here is going to be pi. So if I were to make pi over 6 to be a pi, I would have to be 6 pi over 6. But I'm not quite there. I'm just shy of 6 pi over 6. So that tells me that this one has to be a 5 pi over 6. Let's make that look a whole lot nicer than that. Let's use this bar as my nice fraction. Okay, and again, I was just shy of that pi, so I'm going to go back 1. Same thing, once I hit pi, I know that the next one following that, it's still a 30-degree reference angle. Well, now this time it's a little bit more than pi, so that's where I'm going to get the 7 pi over 6. Jumping into the fourth quadrant now, well, I know that at the end of all this, I'm going to have a 2 pi for my radians. So 2 pi with a denominator of 6 is going to give me a 12 pi over 6. Well, in the fourth quadrant, I'm not quite at 12 pi over 6. I'm only 1 shy. So I'm going to be at 11 pi over 6. Let's do my 45 degrees as well. This one's going to be pi fourths. Now, if we go every pi fourths, the next pi fourth, so next quarter, next 45 degrees is going to put me at 90 degrees. Well, if I added pi fourths with another pi fourths, that's going to give me 2 pi fourths. Simplify that, and that's going to give me pi halves. Rotate another 45 degrees, that puts me right in the middle of that second quadrant. Well, pi fourths plus another pi fourths will now give me 3 pi fourths. Move another pi fourths, that puts me at pi. 4 pi over 4 is at pi. One more pi fourths gives me 5 pi over 4. A second pi fourths is going to give me 6 pi over 4, which can reduce to a 3 pi over 2. And the last pi over 4 is going to give me 7 pi over 4. Notice those denominators are never changing, of course, unless you're at the 90-degree reference angles. Otherwise, they're always over 4. Something to keep in mind. And last but not least, for the 60 degrees, that's going to be our pi over 3. Oops, again, let's use that line as our fraction here. If I start with pi over 3, then the next pi over 3 is going to be 2 pi over 3. The next pi third is going to put me at 3 pi over 3. Well, that's still pi, so I'm at the 180 degrees, that pi side. Then following pi over 3 is going to be a 4 pi over 3. And then one more is going to put me at 5 pi over 3. So that's where they get their radians from. And again, it's going to take some practice. You're not going to get it right away. That's totally okay. But we do need to have it down by next class. All right? So I'm really, really close to finishing. Now I'm just going to use that first quadrant to help me solve everything else. So let's knock out our degrees and then we'll do the coordinates after. So I have the first quadrant, 0, 30, 45, 60, 90. Well, after 90, it's always plus 30, plus 15, plus 15, plus 30. 30, 15, 15, 30. 30, 15, 15, 30. So that's going to give me 120 degrees. 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, 360. A lot of people don't struggle too much with the degrees, so again, if that comes easy to you, great. If it doesn't, you know every single right triangle is 90 degrees. So start with your 90s, break it down to your 45s, and then add 15 to either side. That's another way to do it. All right, now for the last part. For the coordinates, the only thing we have to pay attention to is when it's positive and when it's negative. So I'm going to do the positive, negative sections next, so that I can remind myself, well, which one needs to be positive in this quadrant, which one doesn't. So in quadrant 2, the positive version is going to be sine, but the negative is going to be cosine. Quadrant 3, they're both going to be negative, so I'm going to have none that are positive. Cosine theta is negative and sine theta is negative. In quadrant 2, cosine theta will be positive this time. Sine theta will be negative. This will help me so that when I go to make my coordinates, I can remember which one's positive, which one's negative. All right, let's match the pieces. Let's start in the top left corner, that 2 pi over 3. Well, over 3 is going to match with your pi over 3, so it's the exact same coordinates as you had in that first quadrant. 1 over 2 root 3 over 2. But this time our cosine needs to be negative, so I'm going to fill in a negative sign on my cosine. Follow the pattern. Then I have 3 pi over 4. Well, that's going to match directly with pi over 4. Remember that your cosine in this quadrant has to be negative. Continue that pattern. And we have our 5 pi over 6. At pi, remember your radius is 1, but this time you're on the left side of that x-axis, so it's going to be negative 1 comma 0. Follow that pattern. 7 pi over 6, well, the denominator is 6. This time both answers need to be negative. So it's negative root 3 over 2, negative 1 over 2, negative root 2 over 2, negative root 2 over 2, negative 1 over 2, negative root 3 over 2. At 3 pi over 2, your cosine is 0, but your sine is negative 1. And match the pieces again to quadrant 1. So 5 pi over 3 is going to be 1/2. That's your cosine. It's positive this time. Followed by negative root 3 over 2. Root 2 over 2, negative root 2 over 2, root 3 over 2, and negative 1/2. And there we have it, our entire unit circle. So again, look up some videos. There are tricks. Please look them up. Literally just YouTube unit circle tricks, and find a video that makes sense to you. They are not too terribly long. Practice, practice, practice. Print out blank unit circles over and over and over again. There's nothing wrong. Draw your own unit circle. We have to have this memorized. You will have a quiz on this entire thing next class. I will give you this exact same document. It'll be completely blank with just the respective pieces as empty, so you fill them in. And you will be asked to fill in the entire unit circle. Now, this is a quiz. It's not a test. It's going to take just about maybe 15, 20 minutes of the next class period.